Hey everyone, and welcome back to Gaffy's Grinds. In today's video, we are going to be focusing on the heats of reaction calculation. Always comes up in question 5 or question 6 of the exam. We are going to be looking at the 2019 question today. The first one that we did was the 2020 question. I gave a little bit more help, a little bit more extra explanations and details in that one. If this is your first time seeing one of these videos on this particular question, I would suggest that you do that one first, the 2020 question linked in this playlist. For today, we're going to jump into this one. I'm going to get you guys to pause the video now and have a read from there down to there for me. Pause the video and do that now, please. So as you can see, it starts off the same as anything else. It gives you an overall equation here, and that's always handy because it gives you some of the formulas of the chemicals that you might be talking about. And then it gives you some text where it gives you some names of some chemicals, and it discusses the heats of formation of these chemicals. And then it gives you 1, 2, 3, 4 names in a row, and then it gives you 4 numbers in a row. So the first thing, the hardest thing for you to do is actually to, not the hardest thing, but one of the most important things that you got to do is match up the name of the chemical with its heat of formation. So I'm going to get you to use a highlighter now, and I'm just going to do the first one for you guys today, and then I'm going to get you guys in your exam papers, hopefully you have them in front of you, to highlight the rest. Okay, so I see that the first name I'm coming across here is tetraethyl lead. Okay, that would be this one here, right, guys? This chemical here, C2H5Pb, by the way, tetraethyl lead. Well, I know that lead is Pb, and that's the only thing. Oh, sorry, no, I've got lead oxide here, but hopefully this is pretty easy. That there's 4 ethyls on a lead, and that the heat of formation of that, well, that's the first name, so it must be the first number, so the green one here. All right, so what I want you to do now is, in a different color highlighter, you do the rest of the names and match them with their heats of formation for me. Okay, so obviously, guys, you should only be playing if you've had a go at this now. Obviously, carbon dioxide is the second name. In the equation above that's this chemical, CO2, and this is the number minus 393.5. You might recognize that number from the last question. Carbon dioxide is a very common one in these questions, so you'll get to almost automatically know the numbers. But don't rely on memory for this. They're giving you the numbers for a reason. Use the numbers they give you. Okay, the third chemical name is water, and as you can see, that would be H2O above, right there, and the number here is 285.8. And last of all, what you should have done is, in this little blue color, lead 2 oxide is the fourth one, and that would be this here, PbO, lead oxide, and that's going to give me, that's a heat of formation of minus 219.0. Okay, so it says calculate the heat of reaction for the combustion of 1 mole of tetraethyl lead. So what we got to do first, before we can do anything else, is before we can figure out what the delta H of this is, by the way, this is what we're trying to find out, delta H equals question mark. Well, we've got to work out all of these equations. So you're always going to be involved in deriving the equation for the formation of each of these compounds from the elements. Okay, so what I'm going to do is I'm going to ask you, and you should have watched the last video here, is to try now to derive. You've got 4 equations to derive, forming tetraethyl lead, forming CO2, forming water, and forming lead oxide from the elements. Pause the video and do those now. Okay, so what you should have done here is written the equations. The formation of tetraethyl lead, this is the formula up here. So we're trying to form C2H5, all in brackets, 4, and then Pb. Okay, so what elements make this up? We've got lead, Pb, plus we've got carbon is an element, plus we've got H2 is hydrogen. So you have to remember that hydrogen is a diatom, otherwise you're not going to be able to do any of these. All right, so lead, we've got 1 mole of lead in our product here, so that means we've got 1 mole of lead in our reactant. Remember, this has to stay as a 1 because we need the heat of formation of a compound to be for 1 mole of the compound. So balance everything else to that then. Okay, this is where it might get a little bit tricky. There's a 4 in brackets here, which means 4 times everything inside. So 4 times 2 carbons. So if that tripped you up, again, you've got to be aware of these things. 4 times 2 carbons means 8 carbons here. And then 4 times 5 hydrogens means 20 hydrogens altogether. We've already got H2 here, so this has to be 10 H2s. Okay, so if you can't see what I did here, this was 4 times 5 hydrogens, 20 hydrogen atoms altogether, and there's 2 hydrogen atoms here, so if we have 10 of them, then we have it balanced. And we were told already that the delta H for this is equal to minus 52.7. All right, on to number 2. Okay, forming of carbon dioxide. So forming CO2 from its elements, that's C plus O2. Okay, it's already balanced, so that one's easy. And I'm actually going to keep the delta H's under each other, so I'm going to do it over here. Delta H, we were told, equals minus 393.5. On to equation number 4, the formation of water. So forming H2O, and that means that we're reacting H2 plus O2. Now, that's not fully balanced because we've got too many oxygens. We could change this, but then we wouldn't have the heat of formation of water anymore, because it's always got to be a formation of 1 mole. So I'm going to get rid of that and balance this with a half. That's number 3. And that gave me a delta H, it told me before, was minus 285.8. And last of all, equation number 4, I had to form lead oxide, PbO. So that's it up here. So they always give it to you guys in the equation, PbO. Okay, so what have we got? Pb is my element, plus oxygen is O2. Has to remember it's a diatom. There is 1 atom of oxygen on the right here. As you see, that's only 1. So we have to half this over here to balance it. And that is delta H equals to minus 219. Okay, guys, if you didn't get that fully right, those equations, then what I would say is don't panic. This should be only the second one of these you're doing. We've got loads more to practice. Keep practicing. By the end of them, they'll be second nature, or they should be, if you practice them properly and do enough of them. All right, so after we've written the 4 equations, where do we go from here? Well, after we've written the 4 equations, we have to think about what is the thing we're trying to find, and how do we manipulate our equations so that they'll add up to give us our main equation. So what are we looking for? Now, we've got to be very careful here. I'm going to point this out for you because this is hard, I think, for you guys to see by yourselves. So in this box where it says what we're looking for, what is the equation we're looking for? Now, it kind of seems like they give that to us already up here. This here is the combustion of tetraethyl lead. That's what it says here. Tetraethyl lead burns completely according to the following equation. And it says, calculate the heat of reaction for the combustion of 1 mole of tetraethyl lead. This is the key bit, 1 mole. Always heats of combustion, or heats of any kind of reaction, always have to be about 1 mole. As you can see, I see here 2 moles. So that's a problem. So what I want to do is half all of this equation here. So down below, what I'm going to do is I'm going to try and half all of that. So I have to leave it where we can see it. I'm going to get you guys to do that, please. Pause the video and try and half everything in this equation in this box here for looking for. Pause the video, do that now. Okay, so what we should be doing here is C2H5 in brackets 4Pb. So all we've done here is got rid of the 2 that was before. We don't have 2 moles anymore. We now have 1 mole. Plus, well, we don't need 27 moles of oxygen anymore. We need half of that amount. So that's 13.5 times O2. Or you could say 13.5 O2s. And this reacts to make 16 CO2 halves to 8 CO2. 20 H2Os halves to 10 H2Os. Plus 2 PbOs halves to PbO. So this is our equation that we are looking for, okay? So this is our equation, and again, just like this has a box around it, my suggestion to you at this stage would be also to put a box around it and keep focused on this is what we want our reactions to look like at the end. Again, what we need to do now is I want you to look at these equations up here, okay? We're going to look at these equations, and oh, sorry, my screen's just jumped somewhere else on me. Give me a second to refine this. OneNote can be a bit annoying like this, guys. Sorry. We're well down here. Yeah. A bit. There we go. Okay, and what we want to do is we want to compare our 4 equations up here, number 1, number 2, number 3, and number 4, okay, to this equation. We'll compare these to this equation and find out how would we manipulate the compounds that you see here to get them to look like this equation here, okay? So first of all, I'm seeing in my equation number 1 up here, my compound that I'm interested in is the tetraethyl lead. What I see here is that this is in the products in this reaction, and I want it to be in the reactants in my main equation. So this is in the reactants down here. So when you want to change from the reactants to the products, what we've got to do is reverse the reaction, and that means you've got to change the sign. Okay, so I'm going to go ahead and reverse that down below now. So I'm going to rewrite this out, but reverse it. So that's C2H5, all in brackets, times 4PB. And that's it. And then arrow gives you these three things up here. PB plus, sorry, I need to write it, plus 8Cs plus 10 H2Os. Now, because I've reversed the equation, I have to reverse the sign on this here. That gives me plus 52.7 kilojoules. Okay. And of course, that's, sorry, delta H equals plus 52.7. Okay, let's look at the second equation now. And the compound is CO2. CO2 is already in the products here, up here, and it's in the products. I need it in the products down here. The only difference is that I need 8 of them in this reaction, and this only makes 1 of them. So I'm going to times this by 8. Okay, so I'm going to rewrite this equation down here by timesing everything by 8. 8 C's plus 8 O2s make 8 CO2s. And that's going to give me a delta H equals to, it's a negative number, and what I need to do now is times 393.5 times by 8. Minus 3148. So minus 3148. So a very big number of kilojoules. All right, on to the next one now. My formula, my compound is H2O. Okay, and again, I see that I've got H2O in the products there, and I need H2O in the products here. So what I'm going to do here is I am going to, what do I need to do? I need to times it by 10. Okay, so as you can see, I've got 10 of them down here. So this has to be times by 10. All right, so I've got to take that equation number 3 and multiply everything by 10. So that's 10 H2s plus 10 times a half, which is 5 O2s, reacts to make 10 H2Os. My delta H is going to be a negative number again, and it's 10 times that. So that will give me minus 285.8. Sorry, minus 285.8 times by 10, wasn't it? Times by 10. Gives me 2858. So minus 2858. Okay. And then my last equation I'm looking for has the compound PbO, which is in the products down here, and it's just 1 and 1. So 1 mole here and 1 mole here. So that means I don't need to do anything to it, just rewrite it. Okay, so my third equation is Pb plus half O2 reacts to make PbO, and that gives me delta H equals, and it was minus 219. All right, so now I am again working on turning my equations into, my 4 equations into the 1 equation on the top. Okay, so as you can see, this here already matches this here. So that's good. It's already in the reactants. The next thing I have to do is see, does anything cancel when I try and add things up? Okay. So what I see here is 1 lead here cancels with 1 lead here. So lead in the reactants adds up to with a lead in the products to cancel out. Okay, so Pb and Pb. What else do I have? Carbons. I see 8 carbons here in the reactants is subtracted by 8 carbons in the products. So those atoms are gone now. Okay, in the same way you would do a simultaneous equation. Like terms can be cancelled if they're on the opposite sides of the equation. And then what have we got left over? That looks pretty good to me. What's left over here? Oh, H2s. H2s, they must go as well. Where do they go? One second here now till I find out. And 13.5 oxygens. That must be that first reaction. Did I take that down wrong? Yes, I did. Okay, so I knew I was doing something wrong, guys, because I knew that these hydrogens should not be here. Okay, so 10H2. And I was looking to see this 10H2O. It kind of looks like it should cancel, but then I wasn't entirely sure. So I went back up and read my original here, and look what I've done. 10H2 was the original. So PB plus HC plus 10H2s gives you this. And when I reversed it, I wrote it down with H2O instead of just H2. So there's a mistake that you could make that would rack your brain. But yeah, hopefully you can see that then H2s are gone now. All right, good. So let's write down what's left behind. Obviously, on the product side, we've got this here. So C2H5 in brackets times 4, and it's PB. Okay, plus, okay, all of these guys are all oxygens, look. So we've got 8 oxygens, 8 O2s, 5 O2s, and a half O2. So we add them all up, we get 13.5 or 13.5 O2s. And that's convenient because that's what we had up here. Good. All these react to make, okay, I see 8 CO2s, 8 CO2s, plus 10 H2Os, plus PBO. And what this tells us, the fact that we've ended up with this right, tells us that we've done all the multiplying of the numbers here correct. All the steps that the reaction did, we've done them in the right molar ratios, and that means that these numbers are all right. So what we've got to do is sum up all these numbers now. So we've got plus 52, so 52.7 minus 3148 minus 2858 minus 219. All that reacts to make, so delta H, because it's a delta H for this reaction here, of equals minus 6172.3 kilojoules mole to the minus 1, or kilojoules per mole. Okay, now I'm pretty sure that number seems right. Just going to check my marking scheme here. If you guys have your marking scheme that you can check yourself and you get there before me, that's fine. This here is tetraethyl lead 219. Okay, right. So what I'm seeing is we're a little bit short, minus 6277. Okay, so I'm going to ask you guys to pause the video and see, can you find where we've gone wrong? What mistake have we made? Pause the video, do that now. Okay, so it was probably a tricky enough mistake to find, but it actually wasn't really a mistake. It wasn't your mistake at all, and it wasn't mine right now. What it was, though, is, as you can see where I've written down this information, the heats of formation of tetraethyl lead I have written down was minus 52.7. So when I transcribed this text from the exam question into this box here, so I could organize it for you, I made a mistake. If you go to the original question, this was a positive number. Okay, so this here should be plus 527, which meant that this original number here was a plus And when we reversed it, it should now be a minus. It should now be a negative number, negative 52. Okay. All right, so looking at this sum again now, what we're going to do is pause the video and add up your sum there. Pause the video, do that now, please. The delta H value you should get here is 6277, so minus 6277.7. Okay, and that's kilojoules per mole. Which that's quite a tricky one, but again, same technique as before. And again, it's no harm for a mistake like that to come up and highlight just how important it is that when you're transcribing the values down from the question to your page, that you don't make mistakes with signs and stuff. Otherwise, you are going to lose marks. You won't lose them all. You lose some that it's frustrating to lose marks for something that you know how to do. It's just a stupid slip from moving it from one page to the other. All right, guys, I hope you found this video useful, and I'll see you in the next one.